Okay, so we are at the end of this getting started section. We have this last one to do, more modeling. So let's do this. Okay, so finally we're going to do what they call a predictive model. So finally we're going to make a model. We're going to use the Titanic data. We're going to do some of the things that we've already done before up to here. And then we're going to add in the decision tree to what we've done already. And just like before, when we set the role, we decided we were going to use survival as the variable that we're going to predict, or we could call it the output variable, or here they call it the label. So we're going to do the same thing here. We're going to try and predict who survives. They say at the end of this, they say, of course, there is nothing you can do about this now. In other words, if you build this model and you sort of know what are the factors that allow you to survive, there's nothing you can do about it now after the ship has sunk, but you can maybe still use this model for similar situations and make predictions then. Should you really buy a third-class ticket when traveling with your family? And the model will show you, supposedly. Okay, so let's go through this. So we want to get the Titanic data, and we want to use the set role to choose the output variable. And then we may not want to use all of the attributes, so we're going to use the select attributes. So we're going to do this and put that here. And then we're going to finally put in a decision tree. So let's get that. So this one. And if you wanted to try a different model, you could try all of these different decision trees. There are apparently 8 decision trees. So one of them is famous, called a random forest, which is generally very powerful, usually very accurate. But there are a lot of different algorithms here that you can try. So now we have to set the role here, remember. So we have to choose the attribute name, and this is blank because I haven't connected anything yet. So this node doesn't know anything about the data until I connect it. It doesn't know that I'm working with the Titanic data. It's not connected to the Titanic data yet. So I have to connect it, and then it knows, and I want survived, and I have to change this to label, right? We have to change this to label. This is the role for survived is label. Okay, then select attributes. Let's see what they want us to select. So they're going to say we only want to use, well, before we look at what they want, what might we think would be the important variables that would help us know whether someone is going to survive or not. So would you think the name would be relevant? Probably not, right? By knowing somebody's name, that's not going to really help you, give you any kind of information. How about knowing their gender? So whether they're male or female. Well, I'm not sure, but I know there's a famous phrase that says women and children first. So maybe they use that, and therefore you're more likely to survive if you're a female, maybe. The age, I'm not quite sure how that would be useful or where that would be useful, but it might be. The number of siblings or spouses on board with you, and the number of parents or children on the boat. So yeah, these might be important because if you have a lot of relatives, maybe you have to let them go first, and you might not survive. I'm not sure how that would work either, but these might be important variables to include. Maybe the port of embarkation, but they're not going to actually include that. This one we're not going to include because this is sort of after the fact. So it's sort of cheating to use this because if someone gets in a boat, then clearly, or rather I should say if someone doesn't get in a boat, then clearly they're not going to survive, or I guess it's extremely unlikely that they're going to survive. And that's kind of after the fact because once they get into a boat or once they don't get into a boat, then we already know that they're not going to survive. And so they say, here, they say, we're going to include survived, of course, sex, passenger class, so that apparently might be useful in making this prediction, passenger fare, and the number of parents, children, siblings, and spouses. So those are what they're going to include. So here's their comment here. You didn't select lifeboat because passengers who made it on a lifeboat are likely survivors. Adding this information would lead to trivial models practically only depending on this one piece of information. The real question is actually who made it to a lifeboat in the first place. That's why I said it's kind of after the fact. So who made it to a lifeboat? So we could try and predict that, who made it to a lifeboat. Anyway, name and ticket number are different kinds of ID, so those are really not useful in making the prediction. Okay, so what do we want to include? Which attributes? So we go to here, and we go to not all. Remember, we used subset before, so we're going to use subset. And then they want us to choose survived. So what's wrong here? I guess I haven't connected everything. So this doesn't know the data set yet. So I have to connect it first. And then let's try that again. Okay, now they have it. So survived and sex, passenger class, passenger fare, number of parents, and number of those two, and that's all. So these are the ones that they have decided they're going to include in the model. So let's click on that, and let's click apply. Okay, and then here we have some issue. Oh, haven't connected yet. Okay, and maybe this works. Let's try it out. Oops. Okay. This they didn't tell us to do. So for now, I'm going to leave that out and just do this. And let's see what we get. Okay, so here is the so-called model. And rarely can we sort of visualize a model and see sort of what's going on. But for decision trees, we can. We get an actual tree as an image of the model. So we can see how the algorithm is thinking, so to speak. So let's make it a little smaller here. So what's the top node here? Okay, so the top node, so it's sort of like this is kind of the most important node. So this seems to have more effect in terms of making accurate predictions than the other variables. So anyway, so we can follow it down. Let's follow it down this way. So if the passenger is female, then it checks another variable, and that is the number of siblings. And if the number of siblings is less than 4.5, we go this way. And I guess here, if it's greater than 4.5, can't really see this, but I guess it goes here. So if you have more than, if you're female and you have more than 4.5 siblings or spouses, then unfortunately you are not going to survive. And here when I put the mouse over this, it tells me sort of what the score was on this prediction. So here you can see there are 0 yeses and 6 nos. That means in the actual data set, if when it was a woman and the number of siblings was greater than 4.5, then there were 6 people that fit into that set of categories. So there's 6 people in the entire data set who were women and had more than 4.5 siblings or spouses. So in that case, and of those 6 people, 0 of them survived. So it predicts that you won't survive, and it didn't. And in terms of the real data, no one did survive. So this was completely accurate, 100% accurate. There were no mispredictions. If this had been not 0 and 6, but 1 and 5, that would mean that there was one person who actually survived, but the model here is telling us that you won't survive, so that the model would have made an error for that one person. The model would have predicted that that one person didn't survive, but they actually did. But it doesn't. The data isn't like that. All of the women who had more than 4.5 siblings or spouses on board did not survive. So the model predicted perfectly. Okay, and on the other hand, if we look at, say, over here, so female number of siblings or spouses is less than 4.5, number of parents or children is less than 5.5, and passenger class is second class, then, so following this route down, we would predict that they will survive. And the distribution was that there were actually, in our data set, there were 94 people who actually did survive that fit this specification here. So there were 94 people that did survive, and there were 12 that didn't. So what does that mean? The model said that they will survive, but there were 12 that actually didn't. So the model made mistakes on those 12. Okay, so that's not as, the model didn't work as well in this, if we follow down this path, in this specification, female less than 4.5 of these, less than 5.5 of these, and passenger classes second. So in that case, the model isn't quite as good in terms of the other case. It was 100% correct. In this case, it was pretty nearly 100% correct, but not 100% correct. Now, the other thing is that you can see here that this shows this is a kind of visualization of these numbers here. So most of them are blue, most of them are yes, and just a few of them are no. And over here, all of them are probably yes, right? So here you can see there's no red in here. So in the real data, there were 95 yes and 0 no. So this was, again, a perfect prediction. We say this node is pure. It was all of one type. So it was just all yeses or all blue. Here, there were some yes, mostly yeses, but not all. There were some red. So that's not a pure node, we say. And also the thickness of this tells you that there were a lot of people in this condition, whereas this is quite thin. The width of this line is quite thin, so that's why, and that represents the fact that there aren't so many people that are represented by this node. There are only 6. What do we have here? Just 2 in this node. Okay, so we have run our first model. We've created our first model, our first predictive model. And in this case, since it's a decision tree, we can sort of inspect it the way we've just been inspecting it. It's not always possible. For example, if you have a neural network, there's nothing that you can't understand why it's predicting what it's predicting. You just have to accept the predictions and the accuracy of the model. And we haven't actually checked the overall accuracy of this model, but we will talk about that later. Okay, now just to kind of give the story away, there are many different models that we could have chosen. So we looked in here and we chose decision tree, and a lot of these models were developed in the last 30 years or maybe 40 years, and they were all based on different sort of research papers. Different people had different ideas about how to make predictions given a set of data. How can you take the data and make a prediction? And there are many minds that went into thinking about this, and different people came up with different ideas. So one of them was this decision tree, but other ones are completely different. There's one that you may be familiar with if you studied statistics called regression, which is under the functions category, and it's right here. But there are many others that have people have developed in the last, as I said, about 30 years or so. Now, what's become very useful and the best results are coming from what's called deep learning, which is a type of neural network, which should also be in our list here. Maybe, let's see, is it here? So it's here, neural nets, and we have several different types. And these tend to be the ones that are pursued the most for in the field right now, in business and so on, in science and medicine. So maybe decision trees are not being used that much, but we could choose any one of these. So instead of choosing decision tree, we could try another one. Now, the only issue that we have to think about is that, as we said a little while ago, some of the models cannot handle a nominal output variable, and some of them can. Now, our output variable was survival, and that was either yes or no. So it wasn't a number, it was yes or no. So we say it's nominal, or we could say it's categorical, but whatever it is, it's not numeric. And this apparently works in that case, but some of the other ones may not work in that case. So you just have to understand a little bit more about each model in order just to know whether it will work in that, in the case of a output variable, which is not numeric. So we could just try a different one. So we'll just delete this one, and let's put in a neural network, and let's see if it works. I think we have to reconnect these, and here to here, and then it tells us there's something wrong. Cannot handle binomial attributes. Okay, so this one won't work with binomial attributes. And remember, I said it was a nominal or categorical. It was survival was yes or no, and we call that nominal, but they call it binomial because there's just two of them, yes and no. That's called a binomial attribute. Anyway, it tells us that their form of the neural network cannot handle it. Now, that doesn't mean that somebody else's neural network couldn't handle it. So it's just that the particular form that they have coded here won't work with it. So let's not try that one. So we could just try a different one. So let's try this one, the deep learning one. And let's reconnect these. Maybe we don't have to do this, but we'll just do it. And there's no alert here. Let's give it a try. Now, there are many, if we click on this, there are many parameters to set here, but we'll just leave them as the default parameters. So we'll just try and run it. Okay, so it worked. And of course, this is a completely different output, or the result looks completely different than the tree. And this illustrates the fact that the tree was kind of nice visual representation of what's going on, but this is not much of a, in fact, there's nothing visual about this. These are just numbers. But we will learn how to deal with some of this. But right now, we can just see one thing, and that is if you look here, this is the error. So this tells me that it got 20% of the case predictions wrong. 0.20 is 20%. So that means that it got about 80% of the predictions right, which is pretty good, I'd say, for predicting who's going to survive or not based on the variables that we chose. Anyway, we don't really know how to read most of this, but I'm just pointing out that this part right here, where it says error and total error, does tell you what the percentage of the cases that were incorrectly predicted, and therefore the percentage of cases that were correctly predicted. So here actually you can see that there in our data set apparently there are 1,309 rows. So if we go and look at the Excel sheet, we should find that there are 1,309 rows. Let's see if that's right. So here's 1,310, but the first one was the labels, so that's correct. And then what this means is that it got 268 of those 1,309 incorrect, and so that's 20%. And so the other side is 80%. And then you could try other machine learning algorithms. These are all different machine learning algorithms, and so are these, and so are these, and so on. And you could try all of them and see which one might give the best predictions. Okay, so that is the end of the first tutorial. So they say, congratulations, you finished the first tutorial. You learned how to use the most common data pre-processing operators. So remember, we talked about selecting attributes and setting roles and deleting columns, which is actually select attributes, and adding in new columns and so on. So we learned about those, and we were able to build our first predictive model as well. So they say this is exciting, so celebrate. Okay, so that's where we are now, and we'll stop here.